Hello and welcome. In the previous video, we have solved some questions regarding greatest common divisor and least common multiple. In this video, we will solve some other exercises of greatest common divisor and least common multiple. Let's start. Question number 5. Prove that the GCD of 2n minus 1 and 2n plus 1 is equal to 1. 2n minus 1 and 2n plus 1 are two consecutive odd integers. So this question can be asked as, prove that the GCD of two consecutive odd integer is 1, or we can say that the two consecutive odd integers are relatively prime. Alright, let's start the solution. We assume on contrary that let D is equal to the GCD of 2n minus 1 and 2n plus 1. Now, since D is the GCD, this means D divides 2n minus 1 and D also divides 2n plus 1. And since D divides 2n plus 1 and 2n minus 1, then it must divide their difference. This means D divides 2n plus 1 minus 2n minus 1. And this means D divides 2n plus 1 minus 2n plus 1. And this means D divides 2, because this 2n with minus 2n will be cancelled. Okay. And this means if D is dividing 2, this means D is 1 or D is 2. But D cannot be 2 because D is GCD of 2n minus 1 and 2n plus 1, and both are odd integers. So D cannot be 2, means 2 cannot divide odd integer. Hence D is equal to 1, and that is what we want to prove. Alright. We move to the question number 6. The statement is, let A and B be integers such that 364A plus 277B is equal to 1. Prove that one and only one of A and B is positive and other is negative. It means A and B both cannot be positive at the same time and both cannot be negative at the same time. And the solution is simple. We will see if both will be positive what happened, and if both will be negative then what can be done. Okay, both A and B cannot be positive because otherwise this 364A plus 277B will be greater than 1. Means it cannot be 1 if both are positive. Similarly, both A and B cannot be negative because otherwise this 364A plus 277B will be negative. So only one of A and B will be positive. and the other will be negative. And that is what we want to prove. Alright. We move to the next question. The statement is, suppose a1, a2, b1, b2 are integers such that a1, b1 is equal to, the GCD of a1, b1 is equal to 1 and the GCD of a2, b2 is equal to 1. Is it possible that GCD of a1 plus a2 and b1 plus b2 is 1? They are not asking to prove it general. They just want to know that is it possible? Means we have to give just one example. And the answer is yes, it is possible. Now if we take a1 is equal to 3 and b1 is equal to 4 and similarly a2 is equal to 4 and b2 is equal to 5. Now clearly the GCD of a1 and b1, which is actually GCD of 3 and 4, and we know that the GCD of consecutive integer is 1 because they are relatively prime, and similarly b1 not b1, it is a1, the GCD of a2 and b2 is equal to 4, 5, which is equal to 1. Now the GCD of a1 plus a2, b1 plus b2, which is equal to 3 plus 4 and 4 plus 5 is equal to 7, 9. And in today's video, the first question was that the GCD of two consecutive odd integer is 1. So it is 1. But this is not true in general. We will also give an example. It is possible, yes, but it is not true in general. If we take a1 is equal to 33 and b1 is equal to 35, a2 is equal to 35 and b2 is equal to 37, then we can see that the GCD of a1 and b1 is equal to 1, GCD of a2 and b2 is equal to 1, but the GCD of a1 plus a2, b1 plus b2 is equal to 4. So it is not true in general, but it is possible. Now we move to the next question. The question number 8. If GCD of AB is equal to 1, means A and B are relatively prime, then we have to show that the GCD of A plus B and A minus B is either 1 or 2. Okay. We suppose let D is equal to GCD of A plus B, A minus B. Now we have to show that this D is either 1 or 2. If D is GCD, this means D divides A plus B and D divides A minus B. Alright. This means D must divide A plus B plus A minus B, because D is dividing A plus B as well as A minus B, then D must divide their sum, and this means D divides 2A. Alright, similarly we can show that D divides 2B if we take the difference. Now D divides 2A and D divides 2B, this means D must divide GCD of 2A and 2B. And we know that the GCD of KA, KB is equal to mod of K into GCD of AB. Here GCD of 2A and 2B, which is equal to 2 times GCD of AB, and we know that GCD of AB is 1. So it is 2. Now this means D divides 2 times GCD of AB, and GCD of AB is 1, so D divides 2. Here we can write because GCD of AB is equal to 1. Okay, D divides 2. This means there are 2 possibilities, that D is equal to 1 or D is equal to 2, and that is what we want to prove. And that's all about this video. See you next time.